Not too long ago, ideas like autonomous aircraft, armed robots, and laser weapons seemed impossible, things you'd only hear about in futuristic theories. But today, those once unbelievable concepts are turning into reality, thanks to the advanced work of the US Air Force. Technologies like drones, laser systems, and hypersonic jets are no longer just ideas on paper. They're active projects being developed by some of the world's top experts. So which of these next-generation aircraft could redefine global power as we know it? Let's take a closer look. B-21 Raider, the future of strategic bombers. We start with one of the newest stars of America's nuclear triad, the B-21 Raider, developed by Northrop Grumman, the same team that gave us the iconic B-2 Spirit stealth bomber. The B-21 marks the next generation of strategic bombers. The program kicked off in 2011 under the highly secretive Long Range Strike Bomber (LRSB) initiative, and by 2016, it officially earned its name. B-21 symbolizes the first bomber of the 21st century, while Raider pays tribute to Doolittle's legendary Raiders from World War II. Unmatched range and payload. The B-21 is designed to go the distance, literally, with a projected range of around 6,000 miles and a payload capacity exceeding 20,000 pounds. It continues the legacy of its predecessors like the Rockwell B-1B Lancer and the B-2 Spirit. What sets it apart is its ability to strike anywhere in the world, at any time, and under any conditions. While its top speed of Mach 0.8 isn't the fastest, its massive fuel capacity and in-flight refueling capability make it an unmatched global asset for precision strikes. At first glance, the B-21's design seems similar to the B-2, but under the surface lies decades of innovation. Its deeply recessed air intakes are a critical element of its stealth, a feature that Northrop Grumman engineers undoubtedly spent countless hours perfecting. But perhaps its most groundbreaking advancement is its ability to endure the elements. Unlike the B-2, which requires climate-controlled hangars, the B-21's new stealth coatings and design allow it to sit outside under a simple canopy year-round. This drastically reduces operational costs and increases mission readiness. Furthermore, the B-21 isn't just about nuclear deterrence. While it will carry the next-generation AGM-181 long-range standoff weapon, LRSO, equipped with nuclear warheads, its arsenal will include much more. Electronic warfare-enabled decoys, confusing enemy defenses, anti-radiation missiles designed to take out enemy radar systems, quick-reaction missiles for time-sensitive targets, hypersonic weapons, capable of striking at incredible speeds, combat lasers, emerging technologies that could redefine air warfare, drone integration, acting as a control hub for unmanned systems. The U.S. Air Force is investing heavily in the Raider, estimating a per-unit cost of $700 million. Over the next 30 years, the service plans to spend at least $23 billion to develop, procure, and maintain a fleet of over 100 bombers. The NGAD fighter. However, beyond strategic bombers, the future of U.S. air superiority points to the sixth-generation, next-generation air dominance NGAD fighter, designed to replace the aging F-22 Raptor fleet. The NGAD program aims to create the most advanced fighter ever built, one that ensures American air dominance for decades to come. But what makes NGAD different? The NGAD isn't just a single jet, it's an entire family of systems. At its core is the Penetrating Counter-Air (PCA) platform, a fighter optimized for survivability, stealth, and advanced weapons. Engineers are focusing on streamlined designs that eliminate traditional stabilizers, maximizing stealth while maintaining high-altitude performance. The Air Force is also prioritizing engine innovation. Through programs like the Adaptive Engine Transition Program, AETP, and Next Generation Adaptive Propulsion, NGAP. The NGAD is expected to feature engines that offer longer range, greater efficiency, and unprecedented flexibility. Range over maneuverability. Unlike earlier fighters, NGAD sacrifices some maneuverability to prioritize stealth, range, and payload, trends dictated by modern warfare. Though the fighter's ultimate speed remains speculative, its operating ceiling will match or exceed the F-22's 60,000 feet, giving it a strategic advantage in line-of-sight targeting and communication. The NGAD fleet, estimated at 200 units as of now, won't fly alone. The Air Force is developing collaborative combat aircraft, CCA, essentially drone wingmen, that will accompany NGAD fighters and existing F-35 Lightning II jets. These drones will handle tasks like reconnaissance, electronic warfare, and even weapon delivery. While NGAD fighters aren't expected to carry nuclear payloads, they will likely field the most advanced hypersonic weapons and directed energy lasers, ensuring they stay at the cutting edge of combat capabilities. F/AXX, the Navy's answer to sixth-generation air power. While the U.S. Air Force develops its NGAD fighter, the U.S. Navy is charting its own path toward a sixth-generation fighter under the F/AXX program, designed to replace the aging Boeing F/AY-18E/F Super Hornets and EA-18G Growlers. The F/AXX will also work alongside the Navy's existing fleet of Lockheed Martin F-35C Lightning II fighters. The challenge for the Navy is clear. Adversaries, particularly the PRC and other near-peer nations, are rapidly advancing their long-range coastal defense missile systems. These systems now exceed the operational range of current U.S. Navy fighters, creating a significant threat. As a result, the F/AXX must accomplish two critical objectives: outrange enemy missiles to operate effectively in contested zones, remain undetectable to ensure survivability in hostile airspace. Mid-air refueling, once a crutch for extending fighter range, is no longer a reliable option. This challenge demands a new engine design that can deliver long-range cruising capability while maintaining low observability. The solution mirrors the Air Force's approach with NGAD, adaptive engines. These engines provide the flexibility to cruise efficiently at long distances without compromising performance. Leading the effort is General Electric's XA100 engine, which is currently under development and promises groundbreaking fuel efficiency and thrust. While exact performance specifications remain classified, the emphasis is on pushing the boundaries of range, stealth, and endurance. Furthermore, one of the Navy's key focuses is on supporting autonomous operations. This means the F/AXX could work in tandem with unmanned systems or drones, potentially functioning as a command hub for collaborative combat aircraft, CCA. Such capabilities would enhance situational awareness, extend mission reach, and reduce risks for human pilots. Another defining feature of the F/AXX will be its directed energy weapon systems. These laser-based weapons require significant power and cooling systems, which the aircraft is being specifically designed to accommodate. Such systems could neutralize incoming threats like missiles and drones in real time. In addition to its offensive capabilities, the F/AXX will carry advanced sensors capable of detecting and tracking targets with small radar cross-sections, a critical feature for countering stealth platforms. There's also growing speculation that the fighter will include cyber warfare capabilities, enabling it to disrupt or disable enemy networks during operations. Details about the F/AXX's capabilities, cost, and timeline remain tightly under wraps, as expected with a program of this magnitude. What is clear, however, is that the Navy's next-generation fighter, posed by China and Russia, but will also serve as a foundation for future innovations in air combat. Boeing MQ-25 Stingray. Moreover, drones are becoming an integral part of modern warfare, and the MQ-25 Stingray, developed by Boeing, is a prime example of an advanced unmanned aerial platform. It's the world's first unmanned aerial tanker, designed to boost the capabilities of U.S. Navy carrier-based aircraft. The U.S. military sees the Stingray as a key enabler for the smooth transition to the future sixth-generation fighter, F/AX. By fulfilling the Navy's need for tankers, the Stingray will free up to 30% of the fleet's FA-18EF Super Hornets, while allowing for the addition of more F-35Cs. Initially, there were plans for a more secretive design, including a flying wing concept, but these ideas were eventually scrapped. Still, the Stingray retains stealth elements. Its sleek fuselage, V-shaped tail, and engine air intake are all designed to reduce its radar signature. With the ability to offload over 16,000 pounds of fuel over a range of up to 500 nautical miles, the Stingray is poised to play a crucial role in future operations. Experts were intrigued when, in 2024, stealth anti-ship missiles like the AGM-158CL LRASM appeared among the UAV's payloads. The drone also features an electro-optical sensor under its nose. The Navy plans to acquire 76 of these drones with a projected cost of over $13 billion. Boeing E-7 Wedgetail. That's where the Boeing E-7 Wedgetail comes in, a long-range radar detection and control aircraft. The E-7 is based on the Boeing 737 next generation and is designed to oversee operations involving drones, lasers, and hypersonic weapons. As of 2024, more than 100 units of the E-7 have been ordered. The aircraft is equipped with a fixed active electronically scanned array, AESA, radar, replacing the rotating radar found on the Boeing E-3 Sentry, which the E-7 is set to replace. Originally developed for the Royal Australian Air Force in 1999, the project evolved into a major collaboration between Boeing and Australia, resulting in the Wedgetail program. The E-7's radar antenna has a unique cylindrical shape, which led to the aircraft's nickname, Top Hat. The radar can track both airborne and sea-based targets, manage fighter operations, and even perform terrain searches with a range of up to 373 miles. It also serves as an ELINT, electronic intelligence platform, capable of gathering data up to 528 miles away at altitudes of 30,000 feet. In 2023, the Air Force awarded Boeing a $1.2 billion contract to develop 2 new variants of the E-7 for the United States, with the first aircraft expected to enter service by 2027. What's your pick for the next revolutionary aircraft? Let us know in the comments. If you enjoyed the video, be sure to hit like, subscribe, and tap the notification bell for more content like this. Thanks for watching, and we'll see you in the next one.